Okay. Uh, let's remind the others to join the group. Okay. Interesting. 4, 5, 6, 7. Okay, so let's wait one more minute, I think. Then we have to start. I mean, now I have the updated list for all the students who has to join in this class. I mean, there should be 30 students. Okay, so let's start the course. I think we have to start it. Although there are only a few students who attending the class. Okay, first let's look at our code. Last time we tried to implement a separate shader files, right? The shader files should be separate. We have already changed these two shaders, and write it into separate file. So these two separate files are the shader files. Now today, we're trying to implement a shader class. With the new shader class, we can just make this main file looks neat. And now it looks too many codes. A lot of codes. It's not good. And there's something we don't need it in the future. Not need it in the future, but it's more like we might need it quite a lot. But we don't want to make it be seen here. Okay? So what we will do is, first, let's comment out the part we have already done, this bit, from top, okay? The top. Let's comment out the vertex shader source and the fragment shader source. Because we have already implement these two shader functions in separate files. So let's comment it out. Then, next thing we have to do is we add a new file here. I think in C++, I think in Visual Studio, you did almost the same thing. You click in this area, and I think for this, Visual Studio is add a new file or something like that. So basically, it's a new file. Then we add a header file, just header file, and we call it shader. If you're using Mac, please tick this. If you're using Visual Studio, just create the shader file. Once you create it, first thing I recommend you to do is go back here and under this line, include shader. Add this. So create a header file, name it as shader. And do you care about the uppercase and lowercase, okay? Because this is case sensitive. So if you use shader here, capital S, this is capital S. If you use the lowercase, both of them should be lowercase. Okay? So next, let's go back to the shader file. In this file, you will see some predefined command. This is needed if you have some experience before using programming language like C++. When we have a header file, what the compiler do is copy and paste all this header file into the place where it is first included. So when we include the shader file, it finds the shader file and copy everything here and paste it here. So it might happen that sometimes we might include the shaders file twice. In that case, it might cause some problem because you redefine something. So in order to solve that question, usually we use this framework. If not defined, we define. If we have already defined, we ignore everything here. So this is basically what it means here. Okay, but usually I just do it in another way. I do it in pragma once, so it only compiled once. Then what we do next is we're trying to write a class that can open these two folders. Open these folders, and read these two files, and compile it, and make it as a shader program. Okay? So what we do now, we do it in this way. First, let's include some headers, which are needed to open a file and reading a file. Include string, include fstring. Fstring is for open the file operation. Include string. This is called streaming the file. Include iostring. This is basic input-output. Besides, we also need the GL. OpenGL libraries. Then let's create this class. Class called shader. It might have some public, also private. Okay, so next, let's create some private variable with vertex shader and a fragment shader. For public, we need a program. Okay, so let's finish this constructor and deconstructor. A class should have a constructor and a deconstructor. Constructor is like when you want to instantiate this class, you should always call this function. So it assigns some allocated space and assign some initial value for some local variable, so a private variable and public variable. It should do something like that. So this is constructor. A deconstructor is more like when you finish that, you should clean everything. That's deconstructor. So this is the basic framework. Okay, for the constructor, we might need two paths. How to get to these two files. So this is a constant char vertex parse and the const char fragment parse. So basically, you should know we are not writing something new here. What we do is we try to make our original code looks neat because we have so many things on it. They're all in just one file, which is not good to maintenance for maintenance purpose and not good for writing or debugging. So we write this separate shader file. This shader is actually a class. This class is handling things like find these two shaders. I mean, the shaders are in file, right? They're in core.fs and core.vs. They should be able to find these two files, open the file, read the file, and do the compiling things. That's what we have done already in the main CPP. But we want to write it separately, so the code looks great. And we can reuse a lot of code in the future. So here is the constructor. The constructor should provide the parts where we can find these two files. So next first thing is retrieve the source code from file. Like the string vertex code, fragment code. If string is used to handle the thing like string handles the things like file open, file close, read file. If string, so there's a lot of variable we have to write. But basically, you should notice they are coming in pairs. One vertex, one fragment. One vertex, one fragment. Okay, so let's read file and open it. Since these things are not part of OpenGL, we just show you how to do it, but we will not explain too much about it. If you want to know more, you should go to the internet and search for it. Just think of it as a standard way to open and read a file. To open file, we use the try catch block. So when you're typing, if you see some right curly lines under some place, it means you might have some mistake. If the mistake is in this file, then ignore it. Okay. But if you see some mistake here, you should know you type something wrong. Just fix it in time. I mean, so you know, for example, if you have misspelled this, for example, if you spell this, it might give you some error. Okay, yeah, like this give you some error. So you know there's something wrong here. Fix it. Okay. So during this typing time, just try to minimize all the typos you have made. Once again, just remember these all comes in pairs. V and F, they're all coming in pairs. So one vertex, one fragment. Okay, you had a network problem. In that case, you can watch the replay. Because I don't see anything else to solve your problem. Luckily, it's not my problem. So the rest of the students can hear it. Okay, so let's finish the try and catch block. I mean, we should finish this file by the end of today, so we can catch up with our schedule. So first is open file, shader file, open, and then we give the string vertex path. Shader file, open, fragment path. And string, let's type that. String. Then close the file. I mean, I will finish typing all this and then I will leave you enough time to do copy it. But basically, you know, they're all for the open and stream the file. Okay. Then I'll give you enough time to copy it, to type this thing. Okay, so I think you should be able to type this. This is enough time. If still not, just let me know. You can write something in the discussion area, like not finished. But I think that's enough time. Okay, so this is we try to open the file. We open the file. We use this open function to open the file, and we stream the code because at this time all the files are in the read buffer, in the buffer area. We stream the code. Now this code is stream. First we close the file and then we change the file, convert from string to the string. We know the string, but we don't know the string. Okay, so from the string to string. Then if there's some error happens, we want to have some feedback rather than just stop the code. Okay, so that's why we use the try catch block. Okay, so if there's some failure, some errors, it will print out file not successfully read. Okay, let's have a break, and you can just keep finish this code. Okay, so let's have the task. This is part for open the file and get the code from the file. So using this, we can read the code.fs and the code of VS. VS is short for vertex shader, and FS short for fragment shader. So we can read the fragment shader and the vertex shader. So next, what we will do next is we can compile the shader. But before that, we need to do another conversion, because for OpenGL, it can only handle the C-type char, where shader code vertex code const f shader code. Sorry, should be the C string. Yeah. Then we can just compile the code. Compile shaders. And we will copy and paste a lot of code from our previous function. Okay. So we go back to the main function. Yeah, just a few more seconds, then we will copy and paste a lot of code. I mean, reuse a lot of code. We want to reuse a lot of code rather than just typing everything over and over again in the future. So go back to the main function. We can copy and paste things from here. First, let's copy this to a line of code. GLint success, the place where we define success and info log. Copy and paste here. Then in the main function, we copy here from here to here. Do not copy this type, the data type GLUint. Just type from vertex shader and to here. Paste it here. One thing we should do is change the name vertex shader source to V shader code. V shader code. So change this name to V shader code. Okay, since they are all just copy and paste, it should be very fast. Just make sure you change this to Week4 code. And then we go back here. Keep copying. Copy all this file and paste. Copy. When we try to get the compile status and print out the errors if we have, you see we didn't change anything. It's good part. Right? We copy and paste these lines here. And also copy this part about the fragment. But don't copy this, okay? Just from the fragment until here. And one more thing we should do is change this name to F shader code. So you see, we copy and paste a lot of code, and yeah, we will copy several more lines of code, and then it's almost finished. Okay, so since this is a copy and paste, you should be able to finish that. Just do not forget to change the variable name here to F shader code. I mean, after that, you see there's no error in this file. Okay. Next, go back. Nothing we want to change here is copy things from here to here. Okay. So we have copied until here. Now let's keep copying. Copy things from shader program until this. And paste it here. Yeah. Yeah, it's a lot of errors, but we will fix it later. Just in 1 minute. Copy and paste. Okay, then we will rename this shader program to this program. This and arrow this program. And copy this and change all this name. Once you change one, you see one error goes away. Keep replacing this until all the error goes away. Oh, sorry. Then the constructor is finished. Let's do something for the deconstructor. Because deconstructor is more like when you close, when the program is stopped, you close everything, you should clean the space. Okay. So first we need to detach shader from this program. Vertex shader. And detach shader this program. So these two are detached. Fragment shader. And after detach, we can delete them. Okay, let's delete the shader, which we have already don't need it. We have used it already, and we don't need it anymore. Delete shaders. Vertex shader. Delete shader. Fragment shader. And finally, delete this program. This is deconstructor. So there's one more function for the shader class, which is public, called use. Because you remember, previously we have the use program, and we also need to write this. But now we implement here. Because the program is a public variable for this class, and everything which handling this class should be within this class. I mean, handling all these variables, all the functions should be within the class. Okay. I mean, after that, we can comment out lots of things in the main function, and we can do the same thing, but the code looks very neat. Okay. So let's go back to the main function and copy a lot of things out. We have already got this, so we can comment out from all here, from import compile shaders until this bit. We can comment out all this bit because we have already got them. Okay, so we can keep deleting, commenting out this bit and this bit. So if you see an error, just comment out this line. I mean, two of this line can be commented out. Okay, comment out this and this. I mean, now we replace all these things we have commented out with just 2 lines of code, and everything can be restored. Okay, that's a great part, because we have commented out so many codes, and we can just replace all of them with just 2 lines of codes. So what the first line looks like, we should go here. Because we already replaced everything here, and we should go here, which is shader. Our shader equals shader. Now we provide the parse to that's shaders. Let's see. The way sorry, I typed in the wrong way. It should not in this way. It should in this way. Yes. Shaders. Do not type anything wrong, otherwise you cannot have any result. Okay, this is the first line we needed. So what this line mean? Yeah, I will wait you 1 minute and I will explain to you what this line mean, because this is important. Okay, so this means we try to first find this res folder, and then we get into the folder and find the shaders folder, get into it, and find the open it. I should say open the folder and find this file. Okay, so this is the way how it works. If you see this, it means open it. Okay, so find this folder, open the folder, find this folder, open the folder. So for our code, it's like, okay, so now we are at this level. Okay, this level is same with the main level. First, in these files and folders, we find the res folder. We find this. Okay, and then we open the folder. Okay, open it. Then we find the shaders. Now we find the shaders folder. Open it. Then we find the call.vs. Okay, so this now we find this. This way how it works. And this is same for this part. With this, we can redraw the things. With first we it instantiates the shaders, and then we use the shader. So our shader.use, then everything should be the same. So if you try to run the code, you should be able to see the same thing we have seen before. This is the same thing we have drawn before. Okay. So in this way, we rewrite our code and make the code neat. Okay. Previously, we have a lot of things here. We have a lot of things here. Now we can delete them. We don't delete them now because I just want to leave you some working parts, like how we get there. Okay. So later on, when you see the code, you say, we come from here to here. We just use one line of code to replace all these things, and we just make our shaders in separate file. I mean, this is good because in that way, we can modify the shader code very easily because we can just keep typing the things, focus on how to implement our functions rather than just do something like, okay, always add this quotation mark, change of line mark. That's stupid. I mean, it takes a lot of time. We don't want it. We're just using it in this way. Okay. Yeah, that's basically the main part of this lecture. There one more thing. I'm not wondering if we have talked about this. So I'm just asking. Have we saw the curtain moves? I mean, how I make the curtain moves using the colors? Because someone response to me, it's like it's in Unreal Engine. If I use the Unreal Engine project and I show you a curtain moves, have you seen that before? Because now we draw everything here. We draw the colors here, just assign the color. But in reality, I mean, in game development, we don't do that. We give the colors, we draw the color as we using the texture. So in that way, all the colors should have different way of using. It is use of the some other ways. Okay, so have we seen that before? I mean, an orange curtain just moves. So I'm not wondering if we have seen this before. Okay. Yeah. Okay, just explain it more clearly. Uh, it is because in the real-time world, I mean industrial area, when we have the color, we can also draw something with the texture. I mean, actually, we were if we have seen this, then it's good because I will go back after we see the texture. I know it's the explanation about the curtain may not clear enough at this time, but after we saw how how the texture works, we can go back and see how it looks like, why it looks like that. Okay, that's great. Okay, so the rest of the time, just check the code and because later, I mean, in next lecture, we will have one more assignment. So just check your code, make sure everything works. Okay. I can open this file so you can check if you still have if you made some mistake. Make sure the code works. Then in the next lecture, we will have something. Okay. Yeah. You can see the replay. The replay is always there. Let me see. If you join the class, yeah, I will see the replay. And I will send you a link to the replay. Okay, so that's the end for this lecture. I will just send you the replay of the lecture. Okay. Okay. See you.